So if we take a look at this one, remember we defined volume to be an area times a height or times some other distance or length. So in this case, what shape are we going to find the area of? We're going to treat this as our base, right? The front side of it here. And of course, that's not really just a single shape. We have to do what to it? Break it up. Probably the easiest way would be like that. Maybe we could have cut it side to side as well, about the same. So this first piece here, what's its area going to be? 15 times 6, which is 90 square inches. The second piece is 10 here by how much? This is 15, right? If this is 5, this has to be 10. So that adds up to 15. So 10 by 10 is 100 square inches. And this piece here is 7 by, well, 6 and 10 make 16. This has to be how much? 4 to add up to 20. Giving me 28 square inches. Now, before I go any further, any questions on where I'm coming up with those dimensions like that? That's the skill that a lot of people struggle with. So if you're getting that, you're a good share of the way there. So that adds up to 218 square inches is the area of that base. So to find the volume, what do? Not everybody at once. There we go. 218 square inches times this 5 inches here. Which is going to give us what? 1,090 inches cubed. How many of you got 1,090? There we go. Good deal. Any questions on the homework from yesterday, that page 17 through 19?
I had a question on 37.
37. Okay, let me pull the book out. 37. Trophy company needs a shipping box for a trophy 15 inches high. So let's do some drawing. 15 inches high. 8-inch square base. Like that. The box company is drawing the die to cut the cardboard for this box. How large of a sheet of cardboard is needed to make one box that allows 1 inch for packing and 1 inch for a glue edge, as shown in. Okay, so we're looking at this.
It'd be 15 times 8.
So what we need here, 1 inch for packing. Oh, gotcha. So what it means is instead of 8 inches, this is going to have to be 9 inches. And this is going to have to be 16. So what we're looking at here is you're folding this box up and a glue edge here. So anyway, this is going to be 9 inches. And another 9 inches. And another 9 inches. And another 9 inches. And how big is this going to be? 1 inch. So if we add that all up, that is 37 inches total. Going this way from here to here has to be 16 inches. How big does this have to be?
4 inches.
Well, it's got to be half of 9. It's got to be 4.5 total. Or the two flaps together, this flap and this flap, have to total 9. So that means is this across here has to be 25. Ever see where the 25 came from? Because those two flaps have to fold together to make the full 9 inches there. So we've got 25 by 37. Does it want the number of square inches or just the dimensions? Just the dimensions, so 25 by 37, is that what it listed?
I believe so.
Okay.
Yeah, what I couldn't figure out is how you figured out how the flaps.
Yeah, I mean the flaps just, between the two of the flaps, they got to cover the full 9 inches.
Yeah, that's what I couldn't comprehend is how they arrived at that number.
Sure.
You know,
Well, it's kind of confusing when they say 1 inch for glue. Well, they've got this glue edge drawn in, but does that mean they want the flaps to overlap by 1 inch too, or?
well, yeah, I mean, it was asking me to assume something that, you know, usually don't assume.
Yeah. That one's kind of a tough wording on that one, that's for sure. Any others on the homework you want me to go over? Okay, there are some of you still working on the quiz, and that's fine. Please feel free to take as much time as you need to finish up. Thank you. So if you would set it aside for a little while, we'll cover our new material, and you can come back and finish it up when we get a chance. So we've looked at several types of numbers, and we've looked at order of operations. Today I want to start to bring variables into it. Variables can be used in several different ways. All a variable is just a letter that's being used in place of a number. Now, most common we're used to seeing X, but it could be A, B, Y, N, whatever. And it's used to represent a number that we don't want to put in there for some reason. It could be just a symbolic representation. Like just saying, hey, A equals B. So on a certain drawing or whatever, you have things labeled as A and B. You can put the symbols down there as A equals B. Or in math, we sometimes write some of our rules of math. A plus B equals B plus A. All that's saying is when you're adding two numbers, it doesn't matter what order you do them, they're going to get the same answer. So it can be symbols. It can be, I gotta be careful, an unknown number, but with a definite value. Like 2x minus 7 equals 11. Here we don't know what the x is yet, but it has a definite value. We can find its value by solving the equation. We're going to look at that form in a couple of weeks. Or it can be waiting for a value. So what this is, it's still an unknown number, but it's waiting to have a value given to it. Like volume equals an area times a height. Here, each of those variables is waiting to have a value assigned to it. There are 3 variables here. Now, of course, once we assign a value to any 2 of them, the third one's already determined. But it's still waiting for values to be assigned. This one's different from this one up here because this one, it already has a value. We just don't know what it is. We got to figure out what it is. 9? Good. Today what we're going to concentrate on is this type here, where we're given symbols. Basically, it's a formula. And we're being asked to fill in values that we know for part of that formula to get an answer. So we have all sorts of formulas. Those of you in automotive, you're going to talk about DC electric relatively soon. One of our big formulas in DC electric is voltage equals current times resistance. So if you're in a circuit and you have a resistance of, let's say we have a resistance of 4 ohms. Pretend I actually wrote my own symbol legibly there. 4 ohms, and we have a current of 3 amps. I can figure out what the necessary voltage is here because I have 3 for I and 4 for R. 3 times 4 makes 12. So V, my voltage, is going to be 12 volts. Now, a lot of times a formula that's in original form isn't terribly useful to us. We don't know how to solve equations yet. Once we do, we'll be able to rearrange a formula like this by using our same steps as we would for solving equations. But for now, I'm just going to have to give you the different forms. For example, the amount of current that flows is equal to a voltage divided by a resistance. So if we are given that we have a 24-volt system and that we are running with a resistance of 12 ohms, how do we find the voltage? Or how do we find the current, I should say? What goes, 12 over, or sorry, 24 over 12. Wrote the right numbers, said the wrong one. We divide that out to get 2. We got a current of 2. And those of you in automotive will at some point learn that a volt divided by an ohm is an amp. There are other formulas we can use. I'm still dealing with electricity. The power in a circuit is equal to the voltage squared divided by the resistance. So we can look at, if we have a voltage of 12 volts and a resistance of 4 ohms, how do we find the power? We're going to put 12 in for V. It'll be 12 squared over 4 goes in for R. What's the first thing we have to do to reduce this? Well, we go back to our order of operations. We have the fraction bar, which means we're going to look on top first. On top, we have to do the power, which is going to give us 144. 12 squared is 12 times 12, or 144. Then we can divide by 4 to get 36. The units for power is watts. Again, I wouldn't expect you to know the units, just be able to do the calculations with the numbers. Or it can be listed as power equals the current squared times the resistance. So if I give you that the current is 3 amps, the resistance is 4 ohms, how do you find the power? Well, on your notes quick, find the power for me. Perfect. The 3 goes in for I, that's 3 squared, times 4 goes into R, for R. 3 squared is going to be 9, times 4 is 36. The amount of work done to make a car accelerate, or to accelerate any object, is the mass of the object times the acceleration times the distance that it accelerates. Yes, I realize that spells out mad. That's just a coincidence. So let's say that we have a car with a mass of 1,500 kilograms. Is accelerating at a rate of 4 meters per second 4 meters per second squared. And it does that over a distance of 300 meters. How much work is being done? We're not going to worry about the units. What goes in for M? M is 1,500 times what goes in for A? 4 times it's going to go in for D? 300. So if we multiply that all out, we're going to get 6,018. 1,800,000, I believe. Sound right? The unit would be joules of work. Once we get into the metric system a little bit, we'll be able to move the decimal point and make that 1.8 megajoules. But for right now, we'll leave it as 1,800,000 joules. There are all sorts of other formulas we have out there. They can get more or less complex depending on what we're using. We might have something like this. Where T equals 8, F equals 12, and Z equals 3. I want you guys to plug those numbers in there quick and figure out what M has to be. So we're going to start out plugging the numbers in. So this is going to become 3 times 8 squared plus 4 times 12 over 2 times 3. So what do we do first? Well, we're going to do the top first. What do we do first up there? 8 squared is 64. Then what? 3 times 64 is 192 plus 4 times 12, 48, which adds up to 240. Good. What's next? 2 times 3 is 6. So that's 6 on bottom, and then just divide. 240 times 6 is 40. So the answer is 40. M equals 40. We might have this, where A equals 5, Z equals 3, P equals 12, and M equals 5. Go ahead and substitute those in and figure that out quick, and we'll go over it in a minute. Okay, so help me write this out. What am I going to write here? Seven times 5 plus 3 perfect. Now what do we have to do first? 5 squared, which is 25. Then what? 4 times 12, which is 48. And then 48 minus 25, which is 23. And then we get rid of the parentheses. Then what? Multiply what? 7 times 5 is 35. And then 3 times 23 is 69. And then we add to get 104. So P is 104. What do you think? Doable? Okay, some for you to try. On page 22, 1 through 29, the odds. Just like always, do the first couple. If they seem easy, skip ahead. Well, maybe if you're having trouble with any, we'll maybe take a look at them here in a couple minutes.